Example 10.8.1. The diagram shows a sketch of the curve with equation y equals x squared. The point P lies on the curve. P is just a general point. The rectangle shown shaded has height y and width delta x. So P is a general point. P could be anywhere on this curve, and the height of the rectangle formed from P down to the x-axis is always the y-coordinate at P. So we've been asked to calculate the sum between x is 2 and x is 5 of x squared multiplied by delta x in the limit as delta x tends to 0. So x squared is the same as y. On this particular graph, x squared and y are the same thing. And delta x is the width of this rectangle. So what it's asking us to do is to add together, that's what capital sigma means, sum, add together all the rectangles between x is 2 and x is 5 that have a height of x squared and a width of delta x. So we could draw on lots and lots of rectangles, and our task is to add them all together. Now, I certainly don't recommend you draw the rectangles on the diagram, because what you need to recognize in a question like this, that is, if we send delta x to its limit of 0, in other words, if we make these rectangles infinitesimally thin, then it becomes an integral question. That is where integration comes from. At the top of the screen, we have a paragraph left over from the introduction to this chapter. Integration is the process of adding up. It really is a summation. Whenever we wish to find areas under curves, and in further maths you'll learn how to do that to find volumes as well, we can do this by finding the area, or if we're doing volume of a small portion, like this rectangle here, and then summing of the whole region of interest. And the region of interest here is between x is 2 and x is 5. The calculation can then be performed using the technique of definite integration. So this question is actually the same as the definite integral of x squared dx, so not delta now, dx now, between limits of 2 and 5. These two things are the same. So that means it's quite a simple question now. Raise the power of x by 1, divide by the new power of x. We don't need a plus c because they would cancel out when we put the limits in. So it's a third of 5 cubed, take away a third of 2 cubed. And 5 cubed is 125, 2 cubed is 8. They've got a common denominator already. So that's 117 over 3, which is precisely 39. So the answer to the question, the area of, under the curve between x is 2 and x is 5, it's not approximately 39, it is exactly 39. So the purpose of that example was to help you to recognize that this summation is actually an infinite summation. We're adding up infinitely many really thin strips, and that becomes an integral. That's what an integral is. Okay, that concludes the example.